Okay, time for a morale boost. So, it's late November. It's easy to get bogged down in all the midterms and assignments and stuff. But let's see how far we've come. We haven't seen this table in a video in more than a month, and we've come a long way since then. So maybe we should keep track. What have we seen out of this list of operators? I mean, in most languages, you couldn't get through everything in the language in one semester. But let's see what we've done so far. Okay, we know what round brackets do. I mean, that's an easy one. That was like week 2. And they also can be used for function calls. We've done that as well. We know about square brackets now. That's arrays. We know about the dot. We know about the arrow. That's structure types. We know about plus plus and minus minus. Oh man, do we know about plus plus and minus minus. And we also know about plus plus and minus minus. Okay, so we know about this, the unary operators like writing negative a. Okay, we know about that. We know about the logical not operator. We don't care about the bitwise not operator. We actually have seen casts every now and then, so just to give an example, if I write 6.5 plus 1, well, that expression there is a float, or a double, because we've got float plus int. But what if I want it to be an int? What if I want to force it to be an int? What I can do is I can put the name int in brackets, with brackets on both sides, right before the expression. And the result, this is called a cast, the result is then forced to be an int. And we don't need it so often in C, which is why we don't usually see very much of it. But it is very useful in other languages. Because if I wanted to assign, for example, in Java, if I want to assign this to an int, it won't let me. It'll say that's a float. You can't assign that to an int. I have to forcibly convert it to an int before that'll work. Okay, so that's a thing. We've seen it every now and then, but it hasn't been too much of a big deal. Okay. We've seen the star. We've seen the ampersand. We've definitely spent some time with those. Then there's this one. That's weird. Okay, we'll skip that one and come back to it. So, what else? Well, we've seen multiplication and division in the modulo operator. We've seen plus and minus. There's a bitwise operator. We don't care so much about that. We've seen the relational less than, greater than, less than or equal to, greater than or equal to. Okay, we've seen relational equals and not equals. There's some more bitwise operators. Don't care so much about those. So, there are some things we haven't gotten to. Seen logical and, seen logical or. We have seen ternary conditional. It hasn't been a required part of the course, but it is actually in the notes. We've seen all these assignment ones except for the bitwise ones that we don't care about. And we've seen the comma. So I guess we do have to talk about this. Sizeof. Okay, so why is it just a name? Why doesn't it get to have a symbol? I mean, it is an operator, right? Well, yeah, it's in the table of operators. It is a member of the family. It's just a really weird member of the family. It's the uncle that only comes to like Thanksgiving dinner and starts a political argument or something like that. I mean, they're a member of the family. You have to invite them to holidays, but you sort of don't want to see them the rest of the year. Okay, but we should talk about it. It is a member of the family, and it's deliberate. The reason I haven't talked about it until now is deliberate. And it's because if I had brought it up before we talked about arrays, a lot of people would think that it was the solution to all of our problems with arrays. So what sizeof is supposed to do is tell you how much space something takes up. And it is not a solution to all of our problems. It is a solution to a problem, but actually not a problem we've had yet. And we should talk about it because we're going to have that problem soon. But before I do, I need to make it very clear, it does not solve the problem of knowing the length of an array when you pass the array into a function. It does not. Go ahead and try it. You can't use sizeof inside a function to determine the size of an array that was taken as its argument. Okay, but what does it do then? Well, we've seen already that the types in C have some hierarchy. We know that char has less of a range than short int, which has less of a range than int, which has less of a range than long int. We also know, at least informally, that the type int usually has a range between about -2 billion and +2 billion. But all semester, I've sort of been choosing my words carefully there. Usually has a range, not always, because it turns out that depending on where you compile your C code, if it's on Jupyter Hub versus your own machine versus your phone versus a compiler that's compiling code to run on a dishwasher or something, it turns out the compiler does get some leeway into exactly what the range of those variables is. And that means that it could be significant to your program what range they have, or maybe even to a more mundane extent, how much space they really take up in memory. So maybe I want to clear enough memory to store one int. Well, wait, how much memory do I need? There are times I would need to know that. We like the compiler handling most of that stuff for us. We like that we don't have to choose where in memory do we put the value x. We like that. But there are times where that information might be useful to us. Things like how big is an int in memory? And sizeof is a way of obtaining that. So the first thing to understand is that sizeof isn't a function. So I'm using it like it's a function. Okay, what's going on there? Well, it turns out that the sizeof operator is an operator, and I could write it like this. But I think the consensus in the C programming community is that this is weird looking. I don't like this. This offends my sensibilities. So instead, because as you know, you can put brackets around any expression you want, people do this, and then they get rid of the space here. And of course, that's all cosmetic, but it makes it look like you're calling a function. But you aren't. It's an operator. How do we know this? Well, okay, int is a type. You can't pass a type into a function. You can't. You can pass a variable, but you can't pass a type. So clearly, even if sizeof were a function, it wouldn't be any kind of function that we've ever seen. So to be clear, it's because it isn't. It turns out that it's an operator, and it's actually a very special operator because when the compiler sees it, the compiler converts it to a number immediately. When the code is finally compiled, once the compiler's done, this has been replaced with an actual number. So sizeof is evaluated at compile time, not at runtime. Okay, fine, but what does it do? Sizeof takes an argument, it takes a type or a variable, and it tells you how many bytes does this take up in memory. So in this case, I'm asking for the size of an int. And we could extend that to ask for the size of all sorts of interesting stuff. Here I'm asking for the size of a char, of a double, and then I can also ask for the size of any value, whether it's a type name or not. So I'm asking for the size of a specific type here. I can also say, here's my variable x. And the compiler knows what x is, it's an int, so this will tell you the size of x in memory. And we should expect that if we know the size of an int, the size of x should be the same because x is an int. So let's try running this. Notice I am using this %LD. The result that comes back from sizeof is essentially, for our purposes, a long int. It's got a little bit more of an obscure type, but it's basically a long int. To print out a long int, you use %LD. All right, so an int is 4 bytes. Okay, fair enough. I mean, news to me, I guess. We've gone this whole course without caring about that, and that's deliberate. We shouldn't have to care about that. If you look at one of our optional books, I'm trying to get the name, Olson, the book by Olson. I had to lean back and figure out what the guy's name was. If you look at the book by Olson, it actually has a section in there where it talks about, oh, ints are 4 bytes in size. I really hate that. No, they aren't. They're whatever size the compiler makes them, often 4 bytes. We don't care. But we can use the sizeof operator if we ever care. So we should never, if we need to know the size of an int in our program, assume that it's 4. Always use the sizeof operator to get that size, because it could be different, theoretically, if you compile the code somewhere else. So an int is 4 bytes. A char is 1 byte. That shouldn't surprise us too much. A char should be as small as it possibly can be, and it turns out that 1 byte is basically as small as you can get. And then a double is 8 bytes, and our variable x, which is an int, is 4 bytes, unsurprisingly, and our variable f, which is a float, is also 4 bytes. So a double takes up twice as much space as a float. Well, that doesn't surprise us too much. And you could also check that a short int on this machine is probably 2 bytes, and a long int or a long int, at least one of them is 8 bytes in size. Okay, so why do we care about this? Well, we're about to move into a subject that requires us to manually allocate memory. For certain types of memory allocation, we can't let the compiler do it for us. We have to take control. And when we take control, we have to know all the details, like how much memory do I actually need? If I want an array for 100 ints, I need to know how many bytes that takes up in memory. So what I could do is I could say I need 100 ints. Each int is 4 bytes, so that means I need 400 bytes of memory. And of course, I wouldn't use 4, I would just use the sizeof operator to get that instead. So at the end here, just one last note. Sizeof's not magic. It doesn't help you with that problem we have in C of not knowing the size of an array. I know that it sounds like it should help with that, but it basically doesn't. It can sometimes help you know the size of an array if you're in the same function where the array was created, But obviously, why would that be of very much interest to you if you just created the array yourself? If I pass an array into a function, the array turns into a pointer, and all sizeof can tell me is the size of a pointer variable, which typically isn't very helpful for knowing how many elements are in an array.